Hi friends, let's solve Fourier series, video number 9, problem number 3. It is expand fx equals to x sin x in the interval 0 to 2 pi. Remember, in this function specifically, interval is very important because this function is even. If you plot this function between minus pi to pi, you'll see that this function is even. But 0 to 2 pi it's not even. So that's why this period is important in this function. Let's start. First equation is the standard Fourier series equation. Let this function equals to a0 by 2 plus summation blah blah blah. You can read this. This is a normal equation. Now we have to find out a0, an and bn. So a0 is again the standard equation. a0 equals to 1 by pi 0 to 2 pi fx dx. You just put x sin x dx over here and then integrate. How to integrate this? Let's see this formula. So partial integration u dv dx, u v1 minus u dash v2 plus blah blah blah. But remember one important point in this. Take u as that function which ends and v as that function which never ends. Here x will end after one derivation, but sin x won't end at all. That's why take this as u, this as v, and then solve it. Check this solution. You must get this answer minus 2 because it's a definite integral. Try on your own first. Now let's find an. An equals to again the standard equation 1 upon pi 0 to 2 pi fx cos nx dx. Now substitute this x nx cos nx. Now for this use this formula. See here, divide this by 2 and multiply this by 2. Why this? So that we can separate this. 2 sin a cos b equals to sin a plus b minus sin a minus b. See, this is the formula. So again this is the same as integration by parts, only we have to do it 2 times. One is for this, second is for x into sin n minus x. So there would be 2 integrations. So you solve this, again the same formula uv integral of uv as we have done earlier, and then you must get this answer. Only the point to remember over here is, see here, it's n minus 1 the whole square below. So if n is equals to 1, then the answer would be infinity. That's why it is for n greater than 1. Now you will wonder what about n equals to 1. So n equals to 1 we will find out below. Practice yourself. Your answer must match with this one. Okay. Now next is this. When n equals to 1, then what? So just put n equals to 1. Instead of n, just put 1 1 1 and you will get this answer, sin 2x. Now again the same uv formula, and then you will get this answer. Always remember 0 to 2 pi. So substitute 2 pi once and 0 once. Again for finding bn, the same equation 1 upon pi 0 to 2 pi fx sin nx. Just input this and the same logic goes again. Sin a sin b. The formula for sin a sin b is 2 sin a sin b equals to cos of a minus b minus cos of a plus b. So multiply and divide by 2 to get this equation, and then again solve by integration by parts. Again 2 times, one for this, and you must get the answer. Now the problem is again the same, n minus 1. So it is for n is greater than 1. For n equals to 1, we will again solve below. For n equals to 1, just input this 1 instead of n and you will get this answer, sin square x. Now remember this sin square x. Always try to bring some higher degree equation or higher degree polynomial in single degree because it's easier then. So sin square x, we use this formula 1 minus cos 2x by 2. This formula would be useful to convert sin square to cos x, cos 2x basically. So again the same thing, 2 outside and x and x cos 2x, 2 different integrations. One is by parts and one is single. So you should get this answer, pi. You can solve this in 2 ways. You can either separate this x separate and x cos 2x separate and solve it separately, or you can take this as one function and x as one function, u and this whole as v, and then solve. What we have done over here is taken this as whole function, the whole as v. You can solve it in other way also. So just input the values for a0, then a1, b1, an, bn is 0 for n greater than 1, and b1 is already inputted. So this should be your answer. You can download Yuvaguru app to get these videos, online question banks on your mobile. You can follow us on Facebook and on WhatsApp. Thanks.